Um,
Yeah.
uh,
How'd it go?
can you see me?
Yeah. Well, no, you have your little, whatever you call that.
Trying to, I don't know how to start the video. Let's see.
Your thumbnail or whatever.
It went directly to. Oh, I think I got it right.
There you go.
You can see me now.
Yep. Thank you.
Oh, my answer was 336.
All right. And that's a little bit high. So let's see why. So we got 8 factorial over 4 times 5 factorial. Okay, so
Mm-hmm.
based upon what I taught you a minute ago, that means you have 8 times 7 times 6 times 5, and I'm gonna step it up one notch. 5 factorial.
I, okay. So when I line the five with the five, doesn't that X out too, though, right?
Yep, the 5s go out, the 4s go out, the 3s go out, the 2s
So,
go out, and the
so
1s
I,
go out.
yeah. I mean, I never did nothing with the four yet,
Okay,
so
so yeah,
that's
try.
why I say I only got 336.
Let me.
I haven't did anything with the four. That's what I was
Okay,
asking.
take 336 and divide it by 4.
That'd be 84.
Uh-huh. And that's correct. Good job. Nice work.
So basically, I don't do nothing with the number outside the parentheses to the end of the question.
Exactly. Well, and yeah, because of order operations. So yes. Uh-huh. That's correct. All right. So this next one is the strategy to this one is you've got to like think about like your number of possible combinations. Okay.
Mhm.
And so when we look at this word, what we would do is that we would think to ourselves, how many S's are there? So there's one S. How many E's? One E. How many X's? One X. How many T's? One T. I's? Two
Two,
I's. So two I's.
two L's,
Two
one O,
L's.
one N.
One O and one N, right?
Mm-hmm.
So then, like, and this is a formula. This would be something you'd have to like find and apply. Okay. So like if you're like, where did this come from? It is a sample space formula that you would, when you were doing this problem, you would say to yourself, okay, like, I have to use this formula for this problem. So like back in the day when we had a textbook, you would like have a textbook that would be like, okay, to do this problem. In an online class, you either have My Math Lab that's going to give that to you, or you have a video from the professor. So that's kind of where this comes from. I don't want you to be like, he just pulled this out of magic out of the air. No, it's not that. All right. So I'm going to write the formula first. So this is the formula that you're going to need. When you see this question pop up on My Math Lab, this is the formula that you'll need. All right. So N stands for the number of options. Right. So N is equal to the number of options. Like how much do we have in our set? All right. K. We're going to call this one K sub 1 or K1. K1 is one of these letters.
Uh-huh.
Okay, so like in this case right here, we got K sub 1 factorial, K times K sub 2 factorial times, let me try to be neater so you can see this real well, K sub 3 factorial. I'm going to do one more times K sub 4 factorial, and then I'm going to do dot, dot, dot. Because we have 1, 2, 3, 4, 5, 6, 7, 8 letters. So K basically represents your letters from whatever word you've been given. So since we have 8 letters in this particular problem, we're going to end up, when we plug this into the formula, we're going to have 8 different Ks. Okay, so don't stress that real bad for a second. Like, let's do the problem. And then, like, you'll be like, oh, okay, I see what you're saying. Okay, so in our problem, I'm just going to change color so you can see the difference between our notes and our problem. In our problem right here, our sample space, our n is equal to 10. And the reason it's equal to 10 is because we have one S, one E, one X, one T, one O, one N. So right there, that's 1, 2, 3, 4, 5, 6.
Mm-hmm.
2 I's, that's 8. 2 L's, that's 10.
Mm-hmm.
So we have a total of 10 different things in our sample space. So our n is equal to 10.
Okay.
Okay, so I don't know if you want to like make an arrow to kind of like remind you like why 10, you know, like where did the 10 come from? But you know, K and N are 2 different things. They come from the same thing, but they represent 2 different situations. Okay, so in our, when we plug into our formula, we would have 10 factorial. And then we would start going through our different choices that we had. So for the S's, we had 1S, so we would do 1 factorial. So that represents the first K value.
Mm-hmm.
For the E's, we had 1, so we would do times 1 factorial. For the X's, we had 1.
One.
For the T's, we had 1.
One.
For the I's, we had 2, so we would do 2 factorial. For the L's, we had 2, so we would do 2 factorial. For the I's, we had 1 factorial. And the N's, we had 1 factorial. So the hardest part about this question is remembering where the N comes from and where the K values come from. If you can do that, like if you can make that connection for yourself, make a little note to yourself, this is easy. These are easy questions.
Okay.
All right, so on the bottom, let's just go to the bottom because that's kind of big and messy, but it's actually super easy. I mean, like 1 factorial is 1, right? Because it's like when you do factorial, like when you do 2 factorial, that's just nothing more than 2 times 1, right? And so 2 factorial is equal to 2. 1 factorial is just 1. So essentially what we have right here is 1 times 1 times 1 times 1 times 2, which is 2, times 2, which is 4, times 1 times 1. So that means that the bottom is nothing more than 4. So all of that just gives you a 4. And you can, it would be a waste of your time to plug that in your calculator, but you could. So that's why I think it's better for you to.
Bottom row just equals 4.
Yep. Can you explain it to me again why it's 4?
Because you said 1 times 1 times 1 times 1 equals 1.
Yep.
Times 2 equals 2 times 2 equals 4 times 1 times 1. That just equals 4.
Awesome. Good job. So that means you're understanding factorial. You understand that factorial is like nothing more than just like, you know, just a number times itself. And then you're already able to apply it up here in this.
Mm-hmm.
Okay. Do you still have that app on your phone where
Yes, sir.
can you see if you see the factorial key? So we need to go ahead and do 10 factorial. We need to figure out what that is because that's kind of a mess to do by hand. And it would be cool if you had a calculator that did it. So it's just going to be an exclamation point. if you want, you can hold your phone
I
up.
think I got it on my other app. Hold I think.
If you want to hold the app up so I can see the keyboard, I might be able to like see something that would give me an idea of where to look.
Okay. The app that you told me to download, right?
Yeah, I think that was the one that would be like a scientific calculator.
Yeah. They have a lot of things on here. Hold on. I don't know.
It's not gonna show, is it?
Wait, there it is.
Oh yeah. Oh yeah. All right, let me make it.
I might have to mash a different button to go to different symbols.
Let me see if I can make
Hold
you
on.
full screen somehow. Oh yeah. There we go.
I see the basics. These are the basics.
All right, give me a second to scan. All right, show me the top part of the keyboard. Okay. Yep, so go ahead and change it. It's not there.
Uh,
Nope. We're getting closer. Is there any other options?
yes, sir. Can you see this?
Yeah, I can. Thank you. Nope, it's not on there.
Uh, no. No, I don't think they have it.
All right. Well, it's no problem. I mean, you can do it. I just thought it would be, and the problems that you do, the numbers will be small enough that it's not going to be a hassle.
Mm-hmm.
So, 10 factorial would be 10 times 9 times 8 times 7 times 6,
Wait. Oh, I think I got it. Here, at the bottom, at the bottom. Is that it?
Yeah, man. Awesome. So you type in 10 and then hit that button and it'll kick out the answer for you.
Oh, it has a advertisement before it gives you the answer. That would be 3628800.
Awesome. Okay. Hit divided by 4.
I need to write that down because it's not letting me just plug in the divided by 4. That'd be 362. Okay. Um, 907200.
Good job. So why did we take that big 300,000 number? Why did we divide it by 4? Going back to the scratch work on the computer screen. Where did the 4 come from?
It came from the n equals 10.
Yep. So I don't have it exactly written out, but it was like 363, right? And something.
3. It was 336, I think.
Okay.
Something like
Right.
yeah.
So 336. We'll just round it to that, okay? And then, but that was just our 10 factorial, right? And we had already done the denominator, and the denominator was 4. So that's why we were dividing by 4. So you were taking this and dividing it to get your 90,720. Oops. Excuse me. No. Yeah, I was a little bit, I'm a little bit off because our answer is actually 907,200 is the answer, right?
Yeah.
So I was a little bit off on my 336 number, but you get the idea. That's where so you took your 10 factorial, you divided it by 4. We had to do order of operations. We had to like break it down and kind of like work our way through it. There's a lot of little pieces to this, and it's that. Remember at the very beginning of this conversation, I said to you, it's super important that you write this down, like, so that way when you get this question, if you do on my math lab, you're like, oh, that's that question where you got to like do the n factorial and the k factorial thing, right? And then you go and you look at it and you remember how to set it up. If you can't do the setup, like this problem, you're screwed, right? I mean, you can't do this. So we're done with that question, but are there any questions about it before we move on?
No, not to be honest. To be honest, no.
Okay.
I have everything written out, and you explained it pretty good.
And you'll have the video. You can always skip ahead in the video. So let's go back to 10.1. And let's do that number 1 real quick. So sample space. This is somewhat painful, so I'm going to try to do my very best to like kind of be neat so that you understand like what I'm saying. And then we can talk about what we're going to choose. Remember that when we look at probability, we're looking at our favorable outcome over our total. Okay, so when we look at this right now, like I can already tell you because there are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Our sample space should be 25 because 5 times 5 is 25. Okay, let's see if I get that right. Okay, I feel like I'm not going to, but it just kind of gives you an idea of like what we look at. So writing out your sample space in this particular problem, what we want to think about is that we have a president and a treasurer, right? So let's say that John was the president, and then the T stands for Terry. So then Terry would be the treasurer. Or John could be president, and Anna could be treasurer. Or Chris could be, excuse me, bad job. John could be the president, and Chris could be the treasurer, or John could be the president, and Mary could be the treasurer. So those are all the situations when John would be the president.
Mm-hmm.
Okay, so now we've done John as the president. Let's do Terry as the president. So I'm just going to change color so it kind of just contracts.
So Terry would be the president. John would be the treasurer. Terry would be the president. Anna would be
treasurer. Yeah.
Treasurer, and Terry would be the president again, and Mary would be the treasurer.
Good. Don't forget Chris.
I mean,
yep.
But yeah, so on and so on, and then it goes to Anna being the president.
Yep.
And go down the list.
And so don't get like in the sense where you're like, oh, I got it, because we need to see the sample space. We need to have it in front of us to do this question. So then it would be Anna, John, fire them off. Anna,
Terry, Anna, Chris,
Anna,
and Mary.
Good job. Okay. And then, so Anna's done. So now who's president?
Chris.
Okay, so Chris and who?
John.
Chris and
Mary.
Chris and
Anna.
Good job.
And then Chris and Mary.
Good job. And then one more, right?
Mary president.
John, good job.
Mary and Terry. Mary and Anna. And Mary and Chris.
Sweet. There's our sample space.
Mm-hmm.
Okay. So I was off, right? Because it's not 25. Well, the reason it's not 25 is because, like you can't have John and John. Like in this case right here, we have John and John. So I was accounting for John and John. I was accounting for Terry and Terry. I was accounting for Anna and Chris and Mary and Mary. Well, that's 5 combinations that we don't get to use, right? Because they can't be the president and the treasurer. So if you take away, if you take away 5 from there, there's our sample space, 20. So N is equal to 20. And sure enough, that's what we have over here. We have a total of 20 things, don't we? Yeah. All right. So here's my problem. In our gender fluid world that we live in, right? Like, okay, John, definitely a male, right? So when we think about males and females for this situation, John is definitely a male. Terry. Is Terry a boy or Terry a girl?
I would say a male.
Okay. Anna, pretty straightforward. Anna is more likely going to be female. Chris,
male. Mary, female.
Okay, so Chris and Mary. So, but my thing is like, that would be an issue. Like, for me is like, if you don't tell us which ones are male and females, I mean, Terry, technically, I know Terrys that spell their name that way that are female, right? I know Chris's that are female that spell their name that exact same way. It's not very common, but I know them, so it happens. And so in our case right here, now if we go back to the question, we've established that what's male and what's female. The question says the 2 officers must be the same gender. Okay, so in our sample space, what we want to do now is we want to go through and pick out the people that are the same gender. Okay, so let me get a highlighter. Boom. JT, are they the same? John and Terry are the same gender?
John and Terry, yes.
Yes. John and Anna?
Different.
John and Chris?
Same.
John and Mary?
Different.
All right, the next one's Terry. So Terry's a man. So Terry and John?
Same.
Yep. Terry and Anna?
No, it's different.
Terry and Chris?
Chris, same. And
all right. Sweet.
Terry and Mary got different.
Exactly. Good job. You're on it now. Okay, so let me change colors just because I got a conflict here. Let's go yellow. Anna and John, nope. Anna and Terry, nope. So that whole column's it's got a female in it. Oh, but they have to be the same. So we actually could do, go ahead.
Anna and Mary are the same.
Good job. Okay, next column. Chris and John.
Chris and John the same. Chris and Terry is the same. Chris and Anna are different, and Mary is different.
Okay. Mary and John.
Different.
Mary and Terry.
Different.
Mary and Anna. Yep. Mary and Chris. So we go back to how we do probability, right? And when we do probability, remember we look at it's our favorable outcome on top and our total on the bottom. Where our total is 20. Out of the 20 different things that we could possible ways, how many of them are going to be the same gender? 1,
2, 3, 4, 5, 6, 7, 8.
So 8 out of 20. We simplify that by taking a 4. So we divide by 4, and that gives us 2/5. What you think, man?
A lot of colors. The colors makes it more easier.
Yeah.
So I took a picture of it instead of just writing it out because I don't have those colors.
Okay.
But
awesome. But then you see how in this particular problem, writing out the sample space is important. Like in the other ones, like number 2, it was important because but they had the sample space for us. We didn't have to write it. Number 3, they had the sample space for us. And then we get the next section and the sample space doesn't matter. It's a whole different type of question. All right. So 10.2, number 2. So the fundamental counting principle, I think is what you call it. The fundamental counting principle basically says that that's where factorial comes into play. So in this case right here, it says how many ways could members of the following club line up 9 members for a photograph? So what, like imagine lining these guys up. So it could be Carl, Lisa, Jen, Adam, Jenny, Bill, Tammy, Kate, Joe, right? So once Carl's in front, Carl can't be in front anymore. So there's 9 right here. And then you take Carl, and Carl can't be in the front. Now we have 8 different ways we could choose, like who's going to be next. It could be Lisa, Jen, but Carl can't be there. So, so we have 8 different ways. All right. So now we go to the next spot. We've already chose 2 people. Now there's 7 left. 7 different ways we can line up the people who are left over. And then we choose another person, and they go stand there. And now there'll be 6 ways, 6 people left to choose from. So it's kind of like playing, like, when you were in like middle school and high school, you play like dodgeball, and like, and the coach like lined you up against the wall, and like you choose teams. You like chose 2 captains and you chose teams. It's kind of like that.
Mm-hmm.
It's kind of like, how many different ways could we choose our teams, kind of thing. So you just keep on going. So it's 5 times 4 times 3 times 2 times 1. And so just to kind of run through that one more time, just make sure it sinks in, is that like, so let's say we started the problem off and we chose Lisa first. So Lisa was the leader. So Lisa's chosen. Let me back up. Excuse me. When we want to choose the first person, there are 9 choices for us to choose from. So that's why there's a 9 right there. So let's say Lisa's the first person. So Lisa's chosen. She's in the front of the line. So there's Lisa. Now, to choose the second person, there's 8 people. 1, 2, 3, 4, 5, 6, 7, 8. So that's why we have the 8. Let's just say Adam was chosen next. So Adam is right there. Now there's 7 ways we can choose, 7 different people we could choose for the third spot. And then 6, and then 5, and then 4. So essentially, this is a 9 factorial question. That's the fundamental counting principle.
Mm.
And so you just plug that in your calculator, you find that answer, and that's how straightforward that question is. When you plug that in, you should get 362,880. I would highly suspect that question will pop up in my math lab. What I want you to focus on in the language of that question is, it's a very straightforward question. I want you to think about how, like, you just basically have a group of people and you're trying to figure out, like, how would we line them up? How would we do this? So that way, we had all of our choices. And obviously I tried to give you a little more of an explanation as to why it works, because it might come up somehow in real life, maybe. That's probably the most real life applicable situation that you would come across.
Mm-hmm. Well,
okay.
I ain't gonna lie, you making this sound way easier than when I first seen it. Like when I first got this paper, I was like, oh, like I had to send him an email, like, I cannot turn this in.
Yeah,
I gotta check up with my mans. I was like, I can't. I gotta see what's going. This is crazy. So he told me I can still turn it in. So
okay, great. All right, so here we go. We're going to need kind of a sample space for this one, because it says the counting numbers are to be formed using the digits 0, blah, 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 blah. Determine the number of different possibilities for 2-digit numbers. So first of all, this is like one of those questions where you read it and you're like, what are they even asking for, right? So the bottom line is this: we're looking for possibilities for 2-digit numbers.
Mm-hmm.
And the only numbers we get to use are 0, 4, 1, 5, 7, 8, 3, and 6. So we're going to make a sample space, right? And we're going to have to write the whole sample space because that'll take a long time. But if we're systematic and we're clean about it, then we'll be able to see it. So we're going to have 0 be our first number. So if 0 is our first number, who could be our second number?
4.
4. And then 0, and who could be our second number?
1.
And 0 and
0, 5, 0, 7, 0, 8, 0, 3.
And 0, 6, right? Yeah. So in that row right there, how many combinations do you see? A column. How many in that column?
That's 7.
Awesome. So in this case right here, n is equal to 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now we're going to be able to do that for each one of these situations, right?
You gotta do all numbers.
So there's 1, 2, 3, 4, 5, 6, 7, 8.
8 times 7.
So exactly. So 7 times your 8, you'd have a total of 56. So I'm not gonna lie to you, like, because I want to make sure I did it right. I went ahead and let 4 be the first number because it doesn't. So
4 0, 4 1, 4 5, 4 7, 4 8, 4 3, and 4 6.
Still has 7 in it, doesn't it?
Yes.
So now our theory's working, isn't it? You're gonna have
Yes.
7 in each category, and there's 8 categories, so we'd have a total of 56.
56.
In this case right here, it wasn't necessary to write out the whole sample space because we weren't actually going to look for, like, when we go back to that number 1, we're actually looking for like the number of like same-sex combinations, weren't we? So we had to go back, like once we made the sample space, then we had to go back and count what we were looking for, our favorable outcome. In this case right here, it wasn't about that. It was just like total combinations. All right. So number 3, I'm gonna turn the page. Number 3 is, like when you go to a restaurant and they say that we have, 100,000 different, menu items or different ways you can get your meal. That's what this is basically doing. This is, once again, the fundamental theorem. So you walk into this restaurant, you have 3 choices for a salad. That's not a 5, that's a S. Let me clean it up. You have 3 choices for a salad. I'm gonna go ahead and put a multiplication sign right there. You have 5 choices for your main course. And then you have 6 choices for dessert. So the fundamental counting principle basically says that we can take 3 times 5 times 6. So when we multiply those together, there are 90 possible different meals that you can get.
Exactly.
And that's it. That's how easy it is. It's a basic theory of probability. And when you're looking at sample spaces, okay, letter B. So in a zip code problem, like the biggest thing is to kind of make sure you read and look for whether or not a number can be repeated or not. So it says how many zip codes altogether could be formed using those same 5 digits. Those same 5 digits. Not not 1 through 10 or 1 through 9. You don't get to use whatever numbers you want. You only get to use 2, 5, 9, 6, and 0. Those are the only way. So, it's like, we're not going to take the time to write out all the combinations, but, it's like, so, we have 2, 5, 6, 9, 0, and then we could do 5, 6, 9, 0, 2, and then we could do 6, 9, 0, 2, 5, and like, kind of like start thinking about all the possible combinations, right? But we have this thing called a factorial, which does the same thing for us. And this goes back to that question where we had the people lined up against the wall and we were choosing like who's first, who's second, who's third. Exactly. So we look at these numbers. There are 5 numbers we can choose from for the first digit. So for digit number 1, we have 5 choices. So let's say the first number we used was 0. Mm-hmm. So now we have 4 numbers we can choose from for the second digit. Mm-hmm. And then for digit 3, we would, so let's say we had 9 we used. So for digit 3, we have 3 numbers left to choose from, and so forth, and so on. Mm-hmm. And so that's, once again, that's nothing more than 5 factorial. So conceptually, what I'm hoping you're starting to see here is that when you want to find the number of combinations for something, it's like this factorial thing pops up. And you're maybe kind of starting to understand like why a factorial works, because you're hearing my words, you're hearing like, oh, so when I chose the first number, I had 5 choices. Then I already used 1. So for the next number, I only had 4 choices, and so forth and so on. And I think when you plug that in your calculator, you get 120 possible combinations.
Mm-hmm.
All right, so we got about up to 15 minutes, and so I think I can get through this last set. This is going to go back to 10.1, the from there. So you know, and there's a twist to these questions. The twist to these questions is order. Does order matter or not? Okay, so this is really important. What I'm about to say right here. Okay, so we have two things. We have what's called a permutation. And in a permutation, order
I need to write it out.
matters. And then the other option we have is called a combination.
Yo, hey, give me 15 minutes, bro. Hey, I'm in the Zoom meeting for class. Give me 15 minutes. Yeah. Go ahead.
So what I'm trying to do is create two little categories for you. And these, like I said, this is super duper important. So I heard you say you're going to write this down. That's really smart.
Yeah.
So the first thing you have to ask yourself is are you a permutation or are you a combination? And on all of these questions right here, they don't necessarily tell you which one's which. You have to interpret that yourself first. So we'll address that in just a second. The formula for combination is is C, and I'll explain what this NR stands for in just a minute, okay?
I think the mail lady just pulled up. That's why I was looking outside. I think she got a package or something. She'll leave it at the door though. Yeah.
Christmas?
Some
Christmas
shoes.
in July?
Some shoes. Yeah, I think so.
I'm trying to be as neat as possible. I'm actually going to come down a little bit lower and just rewrite that first part so it's like sequential.
Yeah. It's hard for me it's hard to do like what you're doing.
Yeah.
What you're doing is kind of hard. Like the test that's on my math lab.
Yeah.
We had to we had to show work.
Yeah. He told me he was trying that out.
Man, that's impossible, bro. I'm like, I just was thinking about you. I was like, how do he do this? I was like, bro, I cannot do it. No way. There's no way possible he's doing it. Like, you have to been and did this a long time. Let me unlock this door right quick.
Yeah.
I got like 15 minutes left. Go ahead. Okay.
Okay, so the blue stuff right here, you're looking at the screen, that's supposed to be a fraction. So on top of the fraction is n factorial. On the bottom is n minus r in parentheses factorial. So that's like the top and the bottom. I just didn't want to write on top of the words. I thought it would be confusing.
Okay.
Okay, so go ahead and get that written down real quick, and then we're going to try to figure out what it means to be order and not order.
Okay.
Ready?
Yeah.
Number one. So what I want you to think about right now is as I'm reading this out loud is, does the order matter? In the context of this question, does the order of whatever they're talking about matter? Okay? And I don't even want you to hear anything else about the question besides, does the order they're talking about matter? In a race, does order matter?
In a race, yes.
Yeah, because you're either first, second, or you're last, right? I mean, kind of deal. So right there, that's what tells us this is a permutation. So remember what I was saying to you is like the way you read the first thing you do when you read this is you try to read the question to see if the order that they're talking about, whatever they're talking about, if it matters. Okay, so let's go do the letter B. Okay, so all you want you to think about is the order. Okay, does the order matter? A contractor builds homes of 13 different models and presently has 4 lots to build on. And how many different ways can he arrange the homes on these lots? Assume models will be built, 4 different models. Does the order that these models are built really matter?
No.
No, I mean, you could say yes because you don't want to live in a neighborhood where like there are 4 houses back to back that look exactly the same. But have you ever seen a neighborhood where you had 4 houses in a row that were exactly the same?
Yeah.
Yeah,
I mean,
definitely. Yeah,
like an
because
apartment complex type.
yeah, or even like like in a cookie cutter, like I don't know Thomasville really well as far as like neighborhoods and stuff, but like I'm sure you can think about like those like those neighborhoods you pull into, or like they're maybe like starter homes, and like
Yeah.
and like it's like every house looks the same, and then there's like a unique one, and then they look the same. So in this case right here, order does not matter. It doesn't matter what order we build them in. Like they can be the same. So in this case here, let's go back and talk about that. That means that letter A is because the order matters. Come on. My pen's freaking out on me. Come on. Let me try something real quick. Because the order matters, number 1 is a permutation. Okay. I don't know why it's messing up, man. I'm sorry. Let me see if I can write over here. It seems like it's like partially working. Are you messing with my computer, dude?
Who, me?
I'm just
No.
kidding.
I need this more than you.
All right. And why don't we just type it? This is easy. So order matters. Okay. So since order matters, then this is a permutation. Okay. Down here, because the order does not matter, then this is the combination. All right, so that's the first thing that we look at and we think about is that right there, okay? So now, with that said, we have to identify what our N is and what our R is, okay? Remember, N is just the number of things that we have, and R is the number we want to choose, okay? So in this case right here, N, how many things do we have in this race on number 1?
6.
6. You have 6 cars, right? Out of the 6, how many of them are going to place?
3.
3. So now let's go back into my notes. N is the number of things we have. R is the number that we're going to choose. So we don't give a crap about 4th place, do we? I mean, obviously we probably do, right? But like the bottom line is you get 1st, 2nd, 3rd, that's it. And beyond that, like the other people don't matter. So there's our N and our R. So let's do the same thing in letter B, and then we'll go and apply it into the formulas. So in letter B, what do you think your N is, and what do you think your R is?
Can you repeat that one more time?
Yeah. So I'm trying to break these questions down because they're exactly the same, but they're represent 2 different situations. So first thing we did was talk about like how do we decide if it's permutation or combination?
Mm-hmm.
And now that we do that, we have to identify how do we choose our N and how do we choose our R for this formula over here that we have to plug into.
Okay.
So my question, go ahead. Yeah.
N would be 13.
Good job.
And R would be 4?
You got it. Because you have 13 houses to choose from, like 13 models, but you're only going to build 4, right? So you have 13 choosing 4. On the top one, you have 6 cars choosing 3. So that's how the N and the R work. Okay? The R is always going to be smaller than the N. Does that make sense? You can't choose more than what you already have. Okay, so now what do we do with these guys? We plug them into these formulas. So this, this PNR thing, that's just like saying P6,3 is equal to, and remember, this is our N and this is our R, and then we just plug it into the formula. So that'd be 6 factorial over 6 minus 3 factorial. And then you know how to do that because you already did that in the first section, right? In 10.1, you know how to plug that in and how to simplify that. Okay, on the next one, it would be C 13, 4. And so we plug those in. Remember, this is our N and this is our R. And so that would be, looking at our formula right here, combination formula, that would be 13 factorial over 4 factorial, 13 minus 4 factorial. And once again, you kind of have those skills. I'm going to go ahead and, actually, I don't have the second one worked out. But on top, you should get 120. And on the bottom, like I said, I don't have that one worked out. Let me do it real quick. I'm going to show you a little bit of scratch work real quick on this one. So 13 factorial
13.
over 4 times.
I know for sure I'm going to have to go back and look over. Out of all the problems we've done, to me, this one seems more difficult than the others. At least that's how it's seeming right now.
No, it's culminating. You're building up on things. All right. So when I write this out, whether you plug this in your calculator, because you could plug all this crap in your calculator at one time and get the answer. So you could try that. But I'm just going to show you. So the 9 factorials would cancel. And so at this point, we're left with 13 times 12 times 11 times 10. So I'm going to go ahead and get that number. 13 times 12 times 11 times 10. So that's 17,160 divided by 4 factorial. And then you would solve that from there. And I'm going to go ahead and do that on my calculator. And I got 715 is what you should come out with. So when we in section 10.1, when you were doing these problems and you were like, I was like, they're just trying to get you to learn how to do it. That's because then I was telling you, like, later on, you actually apply it. So that's here you are, you're applying it. All right. On number 2A and 2B, the directions say, tell me if it's a permutation or a combination. So remember, order matters. Okay. So that's what we're looking for. Does the order matter? Okay. Letter A. How many ways can a president, vice president, secretary, treasurer be chosen? So does order matter in that case right there?
Yes.
Okay. So if order matters, and we go back up to our little notes up there, it says permutation. So 2A is a permutation because you said the order matters because the president is more important than the vice president, is more important than the secretary, is more important than the treasurer, right? So that order matters. That's a permutation. Okay. Letter B. To win a lottery in one state, you must correctly select 7 numbers from a collection of 45. The order the order in which the selection is made does not matter. So they told you right there.
Where do you see this at?
7 or 2B. So it's not on my screen. I haven't scrolled down. Sorry.
Oh, okay.
I didn't. My bad. There you go.
I say, I don't know what are you talking about.
I was reading off my handout on my desk, printed out. So that right there in the problem, they told you the order doesn't matter. So you look at your little notes we wrote down. That's a combination.
Mm-hmm.
So based upon that understanding, I'm just going to do P for permutation and C for combination. And right here it says the order does not matter. All right, so I'm out of time. You know, like, I think you should take a look at week 6 assignments. Week 6, even though it's different, it goes along with the premise of the favorable outcome over the total number of outcomes.
Yes, sir.
You know, so when you look at it, it's always going to be like, well, so on top, remember that, and this is for week 6 I'm talking about right now. So for week 6, remember on top, that's what's favorable. That's what they're asking you about over your total possible combinations on the bottom. So once you take a look at that and play around with the homework for week 6 in my math lab and see how that goes, and then just let me know if you have any questions or whatever, okay?
Yes, sir.
All right, man. I will, same thing. I'll upload the video this afternoon and then send you a link. And if you need to come back and watch it, you can. Okay.
Yes, sir.
All right. Hey, for me, you know, like when you have a test, you know, like for me, the assignment of doing the formula sheet is an assignment. And this class is like an accountability class. So, you know, like if you can go back, if you got some things you can turn in, then I can give you some points on those. I know I haven't graded stuff. I've been behind with things, but
I can, I have some things that I could turn in.
Okay, so
it's just last week, like I can't just turn in just some random if I didn't learn nothing.
Yep.
I missed my meeting with you and I ain't know nothing on like I said, what we just went over. So now I have something to turn in. I ain't just want to turn in no bull job. I can't just.
No, for sure.
It doesn't make sense.
Let me show you. Well, and 2, on your, you have Apple phone, right?
Yes, sir.
Like on your Apple phone, the app, the Notes app, like, you know, it's got like yellow at the top. And like, so with that app, you can actually take a screenshot of like a piece of paper. Like, so like if you had like your formula sheet and you wanted to show me, like submit your formula sheet you're using for your test, like, so you can check that assignment off. Like, you know, you can take a picture and then you can just upload that to the computer.
Okay.
So like, that's one way, like you don't have to worry about putting it on your printer and scanning it or whatever. You know, but you can also take a picture of it. You don't have to do the PDF thing. It's up to you. So,
okay.
But that's an option. Okay. But just try to get in there and take a look and like try to get some things attached to those things. And I'll get my grades updated tomorrow for you.
Yes,
and
sir.
so you can look and see, oh, I'm missing that for him. I need to get him something for that. Okay.
Yes, sir.
All right. Sweet, man. Good luck. I'll talk to you soon.
Yep.
Bye.